Hi guys, today we're finding the roots of quadratics in vertex form. So we've seen vertex form quite a bit. Don't forget it's given as a times x minus h squared plus k for quadratics. We've been graphing these, we've been finding vertices, we've been finding min and max and domain and range. Today we're going to have one more tool to that tool belt, which is finding the roots. So just as a reminder, we've got a sample quadratic graph on the left here. The roots go by several names. They also go by x-intercepts. They go by solutions. And they go by zeros. This last one is particularly important. This is called a zero because as these points intersect the x-axis, y is always equal to 0. So when we're solving problems, that's going to come up in just a minute. Okay, and we'll also need our ability to remember how to take square roots. So remembering that when you take the square root of something squared, you get that something out. And here's why. When you're finding the square root, you're finding the number or the term or whatever it is in the inside that multiplies by itself to be that. And so we can expand this a squared into a times a. And actually I'm going to use parentheses instead. And this is going to come in handy in just a minute. So when we have something multiplied by itself, the number that we're looking for the square root of is whatever that number is, and that just gives us a. And the interesting thing about this, that if you have, say for example, the square root of something plus something else, and this is being squared, that's exactly like saying that we have x plus b times x plus b, which is the same thing multiplied by itself. So the square root of a binomial squared is equal to that binomial, whatever that is, which is kind of interesting. And you can kind of think about it as in the squared and the square root cancel each other out. They are inverse functions. Okay, so let's get to an actual problem then. If we have this is in vertex form. We've got a looks like a vertical shift of down 45 units, and we also have 5 times taller. So that's our transformations. When we are trying to find the roots, we don't need to graph these. We don't need to see where they are. We can just use algebra. And remembering this zeros part is a really kind of crucial question. So these questions will say something like, find the roots when they're in vertex form. So the first thing we're going to do is use the fact that roots also hold zeros, where y is equal to 0. So I'm going to change y to be 0. And this one is kind of both in standard form and vertex form. So you could solve this by factoring if you wanted to as well. But we're going to use a square root method is what I like to call this. We're going to do that by eventually taking a square root. So I'm trying to get r by itself in this case. So I'm going to add 45 to both sides. 0 plus 45 is 45. We carry down our 5r squared. We didn't do anything to that term. And then negative 45 plus 45 cancels out. Okay. So, to get r by itself, before we can take the square root, we're going to need to undo this by this multiplication first. So we're going to divide each side by 45. Not by 45, I'm sorry. By 5 is the number right in front of that r squared. That's going to cancel our 5s. We're left with just r squared. 45 divided by 5 is 9. Yes, absolutely. Okay, and then we're looking to undo r squared. So we're looking to get rid of this squared. And we do that by taking the square root. So let's take the square root of both sides. The square root of r squared, just like the square root of a squared, is a. The square root of r squared is r. And the square root of 9 is 2 different numbers. Yes, 3 is the obvious. Take the square root of something.
When we take the square root of something, not only do we have that positive version, so positive 3 times positive 3 gives us 9. We also have the negative version to deal with as well. So not only do we get positive 3 equals r, we also get negative 3 equals r, because negative 3 times negative 3 does give us 9. So most times when you have a quadratic, you'll have 2 roots. Sometimes you'd have 1, sometimes you'd have none. But here are our 2 roots. Okay, second example problem, slightly different than the first. Very clearly this is in vertex form. We've got something binomial squared, so we're inside the parentheses, so it tells we have a horizontal translation to the left 2. We're also flipped upside down from this negative, and it's 2 times taller than normal. We're still going to be asked to find the roots as well. So our first step, just like we did over on the left side, is to change y to be 0.
carry everything else down. And then we need to, again, before we try to take the square root of anything, we've got to get rid of whatever coefficients we're multiplying by. In this case, we're multiplying this by -2. So we're going to divide both sides by that number. So we're going to get 0 equals, the negatives are going to cancel because 0 divided by -2 gives us 0. Negatives cancel, 2 divided by 2 is 1, which gives us just 1x plus 2 quantity squared. And then here, we're actually at the same step. And I know it looks a whole lot different, but we've got something squared, just like we had something squared here. So we're going to take the square root of both sides, and this is a big side to take the square root of, so make sure that your line goes all the way across. And we're going to take the square root of the other side as well. The square root of 0 is 0, and of course -0, but that doesn't make a whole lot of sense. So we're going to have 0 equals whatever we were squaring. So if we got something, we take it squared, we take the square root of it, we just get that something left over. They kind of cancel each other out. So we're left with x plus 2. And then we also could, right over here if we wanted to, we could say -0 equals x plus 2, because -0 times -0 still going to give you 0, but 0 is that special case where negative and a positive don't really matter, so we're going to kind of ignore the solution because -0 is 0, we get the same result on both sides. We're going to finish up by doing some algebra 1 subtraction. So we're going to get x equals -2. This problem just has one root, and that's okay. Alright, make sure that you have written down all the notes. Come find me, get your practice sheet. Let's get this done.